evaluate the definite integral from pi by 6 to pi by 2 of root sine of x times cos of x dx. So we're going to have to use a substitution for this. Two reasons why the substitution is going to be sine x, so u equals sine x. Firstly, because if you have the square root of f of x, as in sine of x in this case, in the function you're trying to integrate, it's often a good place to start, so use that as a substitution. Secondly, if we do have u equals sine of x, then when we do the du by dx and get dx, it's going to give us a cos x in the denominator, which is going to allow us to wipe that out. So let u equal sine x. That means du by dx equals cos x, which means du equals cos x dx, which must mean that dx or du by cos x equals dx. So that's what we're going to substitute. But remember, for a definite integral, we don't need to flick it back to x's at the end. So actually, what we can do is change these limits for u's. So u equals sine x. So when x equals pi by 2, what does u equal? Well, pi is 180, pi by 2 is 90, and sine 90 is 1. When x equals pi by 6, pi by 6 is 30 degrees, sine 30 is 1/2, so quite friendly ones. So now we can transform the integral. So now our transformed integral is the definite integral from 1/2 to 1. So it's going to look a lot friendlier after this. 1/2 to 1 of, so it's square root u, so I'm going to call that u to the 1/2, cos x, and then it's dx, which we've just said is du by cos x, du by cos x. So look at that, cos x, 1, 1. So we now have the integral of u to the 1/2 du, really, really nice integral. So equals it from 1/2 to 1 to 1 of u to the 1/2 du. So now we're ready for the antiderivative bit. Add 1 to the power, divide by the new power. So 1/2 plus 1 is 3/2. So u to the 3/2. And then if we divide by 3/2, we divide by 3 and we times by 2. And we're evaluating that at 1, and that's 1/2. So that must equal, actually, one thing I probably should do. I'm just going to change this 3/2, so it equals 2. U to the 3/2 I'm going to write as u root u. So 2u root u over 3. And we're going to evaluate that at 1 and at 1/2. Okay, so then we just need to evaluate this at 1 and evaluate it at 1/2 and take one away from the other. So it equals 2 times 1 times root 1 over 3. Well, 1 times root 1 is 1 times 1. 2 times 1 times 1 is 2. 2 over 3 minus, then you've got to evaluate this thing at 1/2, which is not so easy. So 2 minus 2 times 1/2, well, that's not too bad, times the square root of 1/2, which must be the square root of 1 over the square root of 2, so that must be 1 over root 2, all over 3. So it's a bit messy, but so it's 2 over 3 minus, well, 2 times 1/2 is just 1 anyway, so that helps. So you end up with 1 over root 2 over 3. So if I do 1 over root 2 over 3, it's the same as 1 over root 2 times 1 over 3. So that must be minus 1 over 3 root 2, which is not bad actually. I could potentially rationalize this. So if I sort of times this by root 2 over root 2, now arguably it won't look any better, but we might as well do it. Now I've written it. So equals 2/3 minus, so that must be root 2 over 3 root 2 times root 2. So root 2 times root 2 is 2. 2 times 3 is 6. And I guess if you wanted to go a little bit further, you could say, well, that's 4 over 6 minus root 2 over 6, so it's kind of 4 minus root 2 all over 6, which probably does look a bit nicer actually.